Assalamu alaikum. In this video I will be doing our lab 7, which is based on interrupts. So first we have a task in which we are sending data. We are basically toggling port P from 0x55 to 0xAA, and we continue doing that until an interrupt button is pressed, which increases the counting from 0 till 255. And so first of all, here we have interrupt library included, avr interrupt.h, and input output library in delay. And then first of all, we are setting the B port to the output direction where our LEDs will be connected, and C port also in the output direction, all pins, because there also we have LEDs connected. And then at port D we are making the pin D2, or we are setting it to the output direction. And now here we are sending this one to the port D2, where it will pull up the resistor. And now here in the EICRA we can see we have set ISC00 and at 1, which is basically that whenever any trigger will happen at the int 0 pin, the we will consider as an interrupt calling. And here in this when we are setting EIMSK int 0 to 1, which means we are turning on the interrupt 0 pin, enabling it. And then SEI is set enable interrupt function, which is basically enabling all our interrupts. The normal function of our code is to toggle the LEDs from 055 to 0AA on port B, and this will continue to happen. And here we have created a interrupt service routine function based on interrupt 0 vector. And here we are simply just increasing what the number we have on the port C. So let's see this code on Proteus. Let's run it. So we can see here, first of all, in the port B there is toggling occurring, which is the normal flow of the code. And as I press the interrupt button, we can see that interrupt has increased to 1, from 0 to 1 interrupt value counts port C value. And while our normal function is not, normal flow of the code of toggling the port B is not disturbed. Let me to change the logic again we can see another increment if I while the toggling is continuously happening. You can see another increment in the port C. So this was the task 1 of our lab 7, which is interrupts. So now this is the task 2 of our interrupt lab. Here we have set again. We have to do the same thing as we did in the previous task, but this time we have to use the pin change interrupts. So again, port B, D and C are set to completely output direction for the LEDs. And then port B0 is set as input. Then we are pulling it up by sending 1 at that pin. And then we have here created the set the PCICR register to we have set the PC interrupt pin change interrupt enable. And then here we are setting the which pin we have to which pin change pin is to be set for the interrupt, and that is pin PC 0 here. And then again we have called the enable interrupt function here. Similarly, we have the ISR interrupt service routine of that, where instead of first we had int 0, which was the normal interrupt external pin, but this time we are using the pin change interrupt, so PC int 0, and then the body remains the same. So now let's run this in the Proteus. So here we can see the toggling is occurring as the normal flow of the code. And let me now change and give the interrupts, and we can see when I give the interrupt, the value of ports increases while the normal toggling is constant. So that was all from this lab. These were the two tasks that we need to perform for the interrupt lab. Thank you.
ये हमारे पास एक्सटर्नल इंटरप्ट का कोड है। जैसे ही हम इसके ऊपर बटन कहते हैं कॉल कराएंगे एक्सटर्नल इंटरप्ट, तो हमारे पास वो कहते हैं एलईडी पे जो भी कहते हैं वाइल लूप से हमारे पास जो भी आ रहा था वो ब्रेक हो जाएगा और हमारे पास ISR पहले एक्सिक्यूट होगा। जैसे SIR कंप्लीट होगा फिर ये दोबारा अपने वाइल लूप पे चला जाएगा। जैसे आप देख सकते हैं बटन क्लिक करने से पहले ISR को कंप्लीट करता है, उसके बाद फिर वो दोबारा वाइल लूप चलेगा।